Hello friends, welcome to JE Cloud, and this is your cloud mentor Gaurish. Today we are going to learn set in detail, so let's move on. The objectives of this session are sets, representation of sets, power set, Venn diagram, operation on sets, laws of algebra of sets, cardinal number of sets, of finite and infinite set. Okay, so we are going to learn in detail. And so the theory of sets was developed by German mathematician George Cantor. The concept of sets is widely used in the foundation of relations, functions, logic, and probability theory, and so on. According to Cantor, a set is any connection into a wall of definite and distinct objects of our intuition or thought. In mathematical language, all living and non-living things in the universe are known as objects. The collection of well-defined distinct objects is known as a set. Well-defined means in a given set, it must be possible to decide whether or not the object belongs to the set, and by distinct means objects should not be repeated. The object in the set is called its member or element, and a set is represented by the braces like or curly brackets like this. Let A is a non-empty set. Capital letter A is a non-empty set. If X is an element of A, then we write as like this and read as X is an element of A or X belongs to A. And if X is not an element of A, then we write like this, X like this, and read as X is not an element of A or X does not belong to A. And for example, if A is the set of all vowels in English alphabets, in this set, the elements will be A, E, I, O, and U. If we take one, let's take I, we can say that I is an element of A or I belongs to A. And if we take another one which is not in this list, that is we can take P, then we can say that P is not an element of A. Here I is an element of A. Now let's look at the question. Which of the following is a correct set? The collection of all months of a year beginning with the letter J, the collection of 10 most talented writers of India, a team of 11 best cricket batsmen of the world, a collection of the most dangerous animals of the world. So let's look each option. Option A, we are sure that the members of this collection are January, June, and July, right? Yes. So this collection is well defined and hence it is a set. We can represent it as a set. Okay. So option A is a set. It is a set. Hmm? And option B, the collection of 10 most talented writers of India. A writer may be most talented for one person and may not be for other. Therefore, it cannot be said accordingly that which writers will be there in the relation. So this collection is not well defined and therefore it is not a set. This is not a set. This is not a set. And so moving to the next one, it is a team of 11 best cricket batsmen of the world. Do you think it's a set? A batsman may be best for one person and may not be so for other. Therefore, it cannot be also or said accordingly that which batsman will be there in our relation. So this collection is not well defined. Hence, it is not also a set. And option D, a collection of most dangerous animals of the world. The most dangerous is not a clear term, right? An animal may be most dangerous to one person and may not be for the other. So it is not well defined collection or it is not a set. So in these options, the right answer will be, or the set will be, option A. So moving on, representation of sets. We can use the following two methods to represent a set. First one, it is listing method. Listing method. And in this method, elements are listed and put within a braces like this, or curly brackets like this, and separated by commas. The elements are separated by the commas, and this method is also known as tabular method. Tabular method, or the roster method. Roster. We have heard about the roster in our textbooks. Roster methods. And for example, a equal to, we can write it as a equal to set of, let it be set of prime numbers less than prime numbers less than prime numbers less than 11, less than 11. Okay, so we can write it in roster form as like this, in the braces, elements separated by the commas 2, 3, 5 and 7, and close the braces. So this is the representation in roster form or listing method or tabular form. Okay, the next one, it is the set builder form. In this method, instead of listing all elements of a set, we list a property or properties satisfied by the elements of set, and we write it as a equal to x such that p of x or x, like also like this, x bar means the such that, or p of x. And it is read as a is set of all elements x such that, all elements x such that x has the property p of x. X has the property p of x. The symbol colon or this bar represents the such that, or stands for the such that. This method is also known as rule method or property method. So what was that? This is the set builder form. Set builder form. Set builder form. So also known as rule method. Rule method. Rule method or property method. Property method. For example, we can write this, write the one in roster form like this: 1, 2, 3, 4, 5, 6, 7, 8. In the set builder form or rule method, it will be like this, in the braces x such that x element of n. X element of n stands for the natural numbers, the set of natural numbers, and x is less than or equal to 8. So by this property, we can define the set, or write in the roster form or any or form that set simply. Okay, and some points to be noted here along the, or regarding the sets are: the order of elements in set has no importance. For example, the set of 1, 2, 3, set of 1, 2, 3, and 3, 1, 2, set 3, 1, 2. 3, 1, 2 are the same sets. Okay, and the repetition of sets of the elements in a set does not affect the set. For example, 1, 2, 3, 1, 2, 3, and set 1, 1, 2, 3, 1, 1, 2, 3. Both are the same sets. So we have used here a capital letter for representing the set of natural numbers. So now we need to take a look at the notation of some standard sets. The notations of some standard sets. The set of all natural numbers, we have told that previous. Set of all natural numbers can be represented by the capital letter n. N equal to set 1, 2, 3, etc. Okay, and set of all numbers can be represented by represented by capital W, that is 0, 1, 2, 3, and etc. And the third one, it is the we can define integers in different ways. So first one, set of all integers can be represented by I or Z. I or Z, that is negative, that includes the negative integers like -2, -1, 0, 1, 2, 3, etc. The negative integers and the positive integers including 0 are there in the I or Z. And the second one, the set of all positive integers or negative integers can be distinctly represented by I plus equal to 1, 2, 3 to the infinity, post plus infinity, and or I minus represented the negative integers, that is -1, 2, -2, -1, -2, -3, and to the negative infinity, to the infinity. Okay. Also the set of even integers or odd integers can also be represented by the letters E, capital E for the even integers like -4, -2, -0, 2, 4, and etc. And for odd integers, O can be represented. For that example, -3, -1, 0, 1, 3, and so on. So now let's look at the rational numbers, represented of rational numbers. The set of all rational numbers can be represented by capital Q. The first one is capital Q. All rational numbers can be included by capital Q. That is P by Q. P by Q, where P and Q, where P and Q are the integers, and Q cannot be equal to 0. Q not equal to 0. Okay, and the next one is option B. The set of irrational numbers. Set of irrational numbers can be represented by IR. And now the set of real numbers can be real numbers. Okay, real numbers can be represented by capital R, which means x such that -infinity less than x less than infinity. They are the real numbers. And the set of complex numbers can be represented by C. And in the set builder form, we can define it as the a plus ib, here b, element a and b are element of R, and I will be equal to root of -1. We know that we are going to study that in detail in complex numbers. So now let's look at a problem. The set builder form of the following set is A equal to 3, 6, 9, 12, and B equal to 1, 4, 9, etc. up to 100. We need to find the set builder form of these two sets from the options given. Here the set A is the, we can see that is the multiples of 3, right? 3, 6, 9, 12, and the B we can see here it is the, is like the perfect squares 1, 4, 9, etc. up to 100. So we can choose for A 3n, it must be like 3n, there is 3n option, and for B it must be n square. So where are the 3n and n square? Option A is also representing that, and B is, all of them are representing the correct. And we need to find the limit now. Limit here, the limit must be 1, 2, 3, 4. Must be between 4 or 4. So option, this option is not correct, and this may be correct. So let's now look for the B also. For the B, it must be between 1 and 10. The 1 square is 1 and 10 square is 100. So here we now we can eliminate option A, and option B, option C. The 10 is not included. It is less than 10. It is told that it is between a 1 and 10. So option C is also wrong, and option B is the correct answer. So now let's look on the different types of sets. So the first one, it is the empty set. Empty set, or otherwise it is also called as void or null set. Okay, and a set which has no element is called an empty set. It is denoted by 5 or empty braces and we can write, for example, A equal to set of all odd numbers divisible by 2. Odd numbers divisible, we know that there are no odd numbers divisible by 2, so it is an empty set or the null set. And another example, so let B equal to x such that x element of n and 5 less than x less than 6. There are no natural numbers between 5 and 6. They may be fractional or decimal numbers, but there are no natural numbers between 5 and 6, so it is also an empty set. And the sets which have at least one element are called the non-void set. If a set have at least one element, then it can be said or called as non-void set. And the caution point to note here, if 5 represents the null set, then 5 is never written within braces. Okay, we can use within braces. If 5 is represented by null set, we cannot use it in braces. Okay, and if we write like this is not a null set. It is a void. It is non-void set. Now if we write in braces, it is not null set, not that. And the next one, it is the singleton set. Singleton. For a set which have only one element is called a singleton set. And for example, a element of, or a equal to x such that x element of n and 3 less than x less than 5. We know that that is the set 4, right? It have only one element, and so it can be called as the singleton set. It must contain only one element. And for the another option or another example, the set 5 is simply a singleton set. And the next one, finite and infinite set. Finite and infinite set. Finite and infinite. What are they? A set in which the process of counting of elements surely comes to an end, it is called a finite set. If the counting comes to an end, it is called the finite set. In other words, a set having finite number of elements is called a finite set, and otherwise it is called infinite set. That is, if the process of counting of elements does not comes to an end in a set, then set is called an infinite set. For example, a equal to set x such that x element of n and x less than 5, and take b equal to set of all elements or all points on a plane like this screen. Okay, on a plane. In these two sets A and B, set A is finite while set B is infinite. Since in a plane any number of points are possible, in this plane any number of points are possible, so that is an infinite set. And the next one is what do you mean by equivalent sets? Equivalent sets. Two finite sets A and B are said to be equivalent if they have the same number of elements. Okay, they can be said to be equivalent, not equal sets. They can be said to be equivalent if they have the same number of elements. For example, if A equal to 1 2 3 1 2 3 and B equal to 3 7 9 3 7 9. Okay, and the number of elements in A is 3 while the number of elements of B is also 3. Okay, also 3, and so we can say that these are equivalent sets. A and B are equivalent sets. Now let's look at the other one, that is the equal sets. If A and B are two non-empty sets and each element of set A is an element of set B and each element of set B is an element of set A, then sets A and B are called equal sets. Symbolically, if x element of A implies x element of B, x element of A implies x element of B, and x element of B implies x element of A, then we can say they are A and B are the equal sets. And now, for example, A equal to set 1 2 3 and B equal to set x such that x element of n and x is less than or equal to 3. Both of them have the same elements. This is in the set builder form, and the other one it is in the roster form. Both of them, this is also set 1 2 3, right? So they are equal sets. Here each element of A is an element of B, also each element of B is an element of A, then both of them can be called as equal sets. And the thing to be noted here is that equal sets are equivalent sets while its converse need not be true. Okay, and the next one, it will be the subset and superset. What do you mean by subset and superset? Subset and superset. Let A and B be two non-empty sets And if each element of set A is an element of set B, then set A is known as subset of B. If each element of set A is an element of set B, then set A is known as subset of set B. And if set A is a subset of set B, then set B is called the superset of A. Superset of A. Also, if A is subset of B, then it is denoted as, if A is a subset of B, then it can be denoted by A is subset of B. A is subset of B, and read as A is subset of B. Okay, and thus if x element of A implies x element of B, then we can write it as x is a subset of B. And if x element of A which implies x not an element of B, x not an element of B, then we can write it as A is not a subset of B. Okay, and for example, if A equal to 1 2 3 set 1 2 3, and B equal to set 1 2 3 4 5. Here each element of A is an element of is 1 2 3 is an element of B, and thus A is a subset of B, and that is A is here we can say that B is a superset of A. Okay, and the caution points are: the null set is a subset of each set. Okay, null set, if you have a question that to write the subsets or all the subsets of that set, then we must write the null set also, and each set is a subset of itself. And if A has n elements, then the number of subsets of set A, if A have n elements, then the number of subsets can be n of s. Number of subsets can be founded by the equation 2 raised to n. Okay, that can be that must be noted. And so the next one, the proper set mean proper subset. What is proper subset? If each element of A is in set B, but set B has at least one element which is not in A, then set A is known as proper subset of set B. And if A is a proper subset of B, then it is written as A is a proper subset of B. There is no that line under C or this symbol, and read as A is proper subset of B. If n, for example, if n equal to 1 2 3 4 etc., and I equal to etc -3 -2 -1 0 1 2 3 and so on, then we can write as n is a proper subset of I. Note that if A has n elements, then number of proper subsets is 2 raised to n minus 1. If n has n elements, I mean if A has n elements, set A has n elements, then the number of proper subsets, that must be noted, the number of proper subsets will be equal to 2 raised to n minus 1. Okay, and now what do you mean by the comparability of sets? So comparability of set. Comparability of set. Comparability. Two sets A and B are said to be comparable if either A is a subset of B, or A is a proper set of B, or B is a proper subset of A. Proper subset of A. A is a proper subset of B, or B is a proper subset of A. Otherwise, A and B are said to be uncomparable or incomparable. For example, suppose A equal to 1, 2, 3, 1, 2, 3, and B equal to set 1, 2, 4, 6, and C equal to 1, 2, 4. C equal to 1, 2, 4. Here A and B are incomparable. A and B are incomparable, but C is a proper subset of B, right? C is a proper subset of B, so B and C are comparable sets. Now look at what is a universal set. What do you mean by universal set? Universal set. If there are some sets under consideration, then there happens to be a set which is a superset of each one of the given sets. Such a set is known as the universal set, and it is denoted by S or U. S or U. It is a superset of all the given sets. Then it can be denoted by S or U. And suppose, for example, A equal to 1, 2, 3, and B equal to 3, 4, 3, 4, 5, and C equal to 7, 8, 9. 7, 8, 9. And now let U equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called the universal set of the other sets A, B, and C. This is the superset of all the sets, so it can be called as the universal set. So that's all for this part. I think we should do some problems also to complete this session, and the next part will be uploading. So let's move on to the next slides. The problem. Consider the following sets: A equal to the set of lines which are parallel to the x-axis, and the B equal to set of letters in English alphabet, C equal to set of animals living on Earth. Which of the following is finite or infinite set? It's a set of lines which is parallel to the x-axis. Infinite set. It's an infinite set. Set A is infinite. I denoted I. And B equal to set of letters in yes, we know that there are only 26 letters in English alphabet, so it is a finite set. This is an infinite set, and C is set of animals living on Earth. There are millions of a lot of animals living on Earth, but it is a finite number, so it is also finite. Set B and C are finite, while the set A is infinite. So the answer will be set A is infinite. Yes, the option B will be the right answer. Option B. And then moving to the next question. The two finite sets have m and n elements respectively. The total number of subsets of the first set is 56, more than the total number of the subsets of the second set. What are the values of m and n respectively? Since the total possible subsets of set A and B are 2 raised to m, 2 raised to m, and 2 raised to n. 2 raised to m and 2 raised to n respectively. According to the given condition, 2 raised to m minus 2 raised to n, the difference of sets. Okay, that is 2 raised to m minus 2 raised to n must be equal to 56. Must be equal to 56. So here we can take the 2 raised to n common, then 2 raised to n into 2 raised to m minus n, 2 raised to m minus n minus 1. This got by dividing this 2 raised to m divided by 2 raised to n. So 2 raised to m comes up, it will become 2 raised to minus n. So we can write 2 raised to m minus 2 raised to n, and that must be equal to 56. That must be equal to 56. This 56 can be written as 2 raised to 3. 2 raised to 3 multiplied by 2 raised to 3 minus 1. 2 raised to 3 multiplied by 2 raised to 3 minus 1. So comparing on both sides, we can write it as 2 raised to n equal to 2 raised to 3. 2 raised to n equal to 2 raised to 3. And here, and 2 raised to m minus 1. 2 raised to m minus 1 equal to 2 raised to 3. 2 raised to 3. And so from here, we get n equal to 3. And from here, m minus 1 equal to 3, and m will be equal to m minus n. Sorry, n. Here not 1, it is m minus n. M minus n equal to 3. So m will be equal to 3 plus n, and n we got here as 3. So 3 plus 3 will be equal to 6. So the correct option will be m will be 6 and n will be 3. So option B is the correct answer. So let's see in the next part. And to know more about the cloud vendor, visit our website. You can Google by typing cloud vendor Gaurish. Site appears as the first result, or simply search cloud vendor and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.